Welcome to the project demonstration of design of micro-inverter. So in this project we are converting 12 volts DC to 230 volts AC with help of this micro-inverter. So this is based on the RLC oscillator. So here by using this resistor, inductor and capacitor RLC. So from this RLC oscillator we are going to generate the 50 hertz of pulses. So that pulses will be given as input to this gate of these two MOSFETs. Means this 12 volts DC converted into the 12 volts AC, and in order to get the 12 volts AC 1 amp, so we are making use of these two MOSFETs. So the signal will be given to these MOSFETs. So after this MOSFET we will get the 12 volts AC, which is current of 1 amp. So the output from this MOSFET driver circuitry given as input to this step-up transformer. So there we are going to step up the 12 volts 1 amp AC to 230 volts 1 amp AC output. So that was given input to this load through this diodes as well as a capacitor. So here these two are used to remove the generated pulses after this step-up transformer. So that is given as input to our load directly. So here we are using 12 volts DC 1 amp battery. So here we can observe the three 4 volt 1 amp batteries are connected in series. So we will get 12 volt 1 amp. So the output from this given to the input to this inverters micro inverter circuits. So this is a rechargeable battery. In order to recharge this battery, so this is a charger. So we are going to provide the 230 volts AC input to this transformer. So on this charging circuit, we can observe the DB107, so which is the IC version of full wave bridge rectifier. So after this, we will get the pulsating DC, and we need to remove the pulses to get the pure DC voltage. So for that purpose, we are making use of 1000 microfarad capacitor, which will act as a smoothing purpose. So after that, there are the two diodes and 1 kilo ohm resistor, which is act as a current limiting resistor for this LED, which will show the status of this charging circuit working. And next, these two diodes will act as a unidirectional current flow purpose. Means whenever the battery is fully charged, so then it will become the high potential one and the transformer will become the low potential one. So in order to block the current flow from the battery to the transformer, these two diodes act as a current unidirectional current flow circuit. So because the diode can allow the currents from one direction to the another direction only, so it will act as a reverse bias when we provide the positive to the negative terminal of this diodes. So in this way we are going to step down the 230 volts AC to 12 volts AC, and from there 12 volts AC to 12 volts pulsating DC, and then pure DC after this smoothing capacitor, and that pure DC voltage of 12 volts given as charging voltage to the battery. So it will be fully charged in a duration of 8 to 10 hours. So in that duration you need to keep on this charging circuit, and once the time is complete you can switch off that. So if you didn't switch off that also, the diodes will block the current flow as they are acting as a unidirectional current flow one. So when it's fully charged one, so connect the AC load over here. So don't use more than the 20 watts because we developed this micro inverter for the 20 watts AC load. So when we switch on this, then there is a light indication on this bulb, so we can see that. So the procedure is 12 volts DC to 12 volts AC, and then after 12 volts 1 amp AC and 230 volts AC directly to the load.